Okay, I want to apologize because as I made this recording for our class session, I had the wrong camera turned on. Those of you who were in the class session saw me work with these triangles on the board, but if you weren't in the class session and you're just looking at the class recording, all you see is my icon. So I want to quickly run through these three triangles to make sure that everybody more or less sees the same presentation. These are the three famous triangles that you need to know: 45, 45, 90, 30, 60, 90, and 15, 75, 90. You learn them by the ratios of their sides. In a 45, 45, 90 triangle, the two legs have to have the same length. And if each leg is length 1, then the hypotenuse is root 2. But because of the similarity of triangles, you can judge any 45, 45, 90 triangle with that ratio. If the legs are length 10, then the hypotenuse is 10 root 2. If the leg is length 7, then the hypotenuse has a length of 7 times root 2. So this is the value of knowing the standard triangles and knowing that similar triangles have the same ratio of corresponding sides. Here in a 30, 60, 90 triangle, the thing to remember is that the short leg is always 1/2 of the length of the hypotenuse. Or you could say that the hypotenuse is always twice the length of the short leg. So if you remember this ratio, you can do any 30, 60, 90 triangle. If someone says they have a 30, 60, 90 triangle, where the short side is 5 units, then the hypotenuse has to be 10 units. And the length of the long leg has to be 5 times the square root of 3 units. What happens if only one is told the hypotenuse? In a 30, 60, 90 triangle, if the hypotenuse is 7, then the short leg is 1/2 of the hypotenuse, 7 over 2. And the long leg is root 3 times the short leg, 7 over 2 times root 3. Maybe the hardest case for a 30, 60, 90 is what happens when someone says, let's make the long leg 10. Well, then you have to think to yourself, how do you move from the long leg to the short leg? This is the guidepost. The instructions are divide by root 3. So if you want to go from a long leg of 10 to the short leg in a 30, 60, 90 triangle, all you have to do is divide by root 3. To go to the hypotenuse from the short leg, you double the length of the short leg, 20 over the square root of 3. So think of the legs of these standard triangles as the instructions for moving from one leg to another. If you have one number, how do you move to the next number? In a 15, 15, 75 triangle, 15, 75, 90 triangle, we have this odd ratio of sides. But as I was saying previously, the poetry of those numbers makes it worth remembering. I also want to remember the 15-degree angle because 15, 30, 45, they're all multiples of each other. And I can use that to understand the ratios of any size triangle. So the ratio of the sides in a 15, 75, 90 uses a 4, and the root 6 minus root 2, and the root 6 plus root 2. I don't know what root 6 plus root 2 is unless I look on a calculator. Same with root 6 minus root 2. But I can use those numbers as ratios. For example, if someone gave me a 15, 75, 90 triangle and said this side was 1, then I can decide how to name the other two sides from that information. How do you turn root 6 minus root 2 into 4? Well, literally, if you want to turn root 6 minus root 2 into 4, you have to multiply by 4 over root 6 minus root 2. That's the instructions for changing the short leg into the hypotenuse. Multiply by 4 over root 6 minus root 2. But now that I know those instructions, I can use it to find the hypotenuse if the short leg is 1. Multiply 1 times 4 over root 6 minus root 2. And then the hypotenuse length is 4 over root 6 minus root 2. How do I go from the short leg to the long leg? If I want to go from root 6 minus root 2 to root 6 plus root 2, I'm writing a little bit small there, I must multiply by root 6 plus root 2 divided by root 6 minus root 2. That's the instruction for moving from this side to that side. How do I find the long side now? I'll multiply 1 times root 6 plus root 2 over root 6 minus root 2. What if this is a 5? If I multiply the 1 by 5, how does that change these two answers? I'll just multiply this by 5. If I made this side 5 times as large, this side becomes 5 times as large too. That's the value of a similar triangles. If I multiply this side, make it 5 times larger than it was, I will put the 5 there and multiply by root 6 plus root 2 over root 6 minus root 2. And then I just get 5 times root 6 plus root 2 over root 6 minus root 2. Now, admittedly, these numbers are awkward to deal with, but the principle of similar triangles is the same for every triangle, not just the right triangles, but the right triangles are the ones we're going to use most often. Now, sometimes you want to use right triangles with the hypotenuse equal to 1 because you want to have the triangles have the same hypotenuse length. And here I've drawn them pretty close to the same. If that's the case, you still use this ratio of sides. If the hypotenuse is 1, how do you learn the leg's length? Well, to go from root 2 to 1, you divided by root 2. That was the instruction. So to go from 1 to the length of this side, you just take 1 divided by the square root of 2. Each leg has the same length. Remember, if you rationalize the denominators, 1 divided by the square root of 2, multiply root 2, numerator, denominator. You get root 2 over 2. So you could express that either way. How about here? What's the instruction for going to hypotenuse to leg? You cut the length in half. So if you want the hypotenuse to be 1, you will cut the length in half to name the short leg. And you will multiply by root 3 to name the long leg. Lastly here, if you divide by 4, this would become a 1. If you divide that length by 4, you divide the other lengths by 4 as well. Okay, it's just a quick way to reinforce the value of the 45, 45, 90, 30, 60, 90, and 15, 75, 90 triangles. And help you to understand it's not just 3 triangles. It's infinitely many triangles. Any triangle that's similar to these has the same ratio of these. and you can translate from one size to another just about instantly.